Our engineering design project aimed at assisting visually impaired swimmers in lawn training. Here is how our device would work. It is composed of two parts. The first is situated on the side of the pool in a transparent splash-proof case. It contains a Pixie 2 camera. This camera is specialized in color detection. Since it can be programmed to detect specific objects, the idea is that it identifies when the cap that the user is wearing has entered its range. These are connected to a Raspberry Pi. Raspberry Pi has a simple user interface, a microSD card for an operating system and storing data, and allows for connections via Bluetooth. The Bluetooth signal it sends is to be picked up by the wearable part of the device, which is located at the back of the cap, in a vacuum-sealed, watertight bag. The wearable device contains this simple circuit, which connects a microbit to a 3 volts power supply and to a series of DC coin motors, which vibrate when the circuit is closed. The microbit is also convenient for its small size and for its flat shape. It has a simple user interface. It is a microprocessor, and it also supports Bluetooth. To summarize, when the Pixie camera detects the cap, a Bluetooth signal will be sent by the Raspberry Pi and picked up by the microbit, whose normally high pins will switch to low and activate the motors, which vibrate to be felt by the user. We chose this concept as a solution to our task for multiple reasons. We gathered from discussions with potential users that the device couldn't impede motion, so we scratched the idea of mechanical solutions present at the end of the pool. In addition, feedback through earphones was said to be too alienating. We also wanted to allow for multiple swimmers to use the same lane. Thanks to the Pixie 2 camera, caps of different colors can have different signatures up to 7 swimmers, allowing for multiple users to employ a single poolside component. User requirements were taken as the criteria for determining the success of the project. The setup of the poolside component is still too uncertain, as it relies on a trial and error approach, which would result complicated for the user to do independently. Motion is not impeded by the device, which we also deemed affordable, as it costed around £300. Accuracy and reliability are marked in orange, as they were dependent on poolside component setup, the color and position of the cap used, and the swimming style. Further tests would give a more accurate indication of how reliable the device is. The device is indeed portable, as it fits into a backpack and weighs under 10 kilograms. Usability could be improved by providing an audio manual or a braille leaflet. Finally, laboratory testing suggests that the device is waterproof and able to withstand submersion. Having this in mind, here are future improvements that could enhance the device. Independent and easy setup, which can be achieved by incorporating a braille measuring tape. Higher setup and positioning versatility, for example by providing a tripod or a ramp to allow better adjustments of the angle of the poolside component. Smaller and purpose-built integrated chips, possibility of wireless battery charging, braille adaptation for component labeling, and the use of a camera with superior resolution and color identification. We are Swiftswim, and we thank you for listening.